Okay. Thanks, Ken. Yeah, well, hi everyone. My name is Luis Cuevas. I'm the section chair for the AIAA LA section. Thank you so much for joining us this morning here in lovely SoCal. Thank you, Professor Loeb, for being here. Um, so today we have a very special subject to introduce, and we have a very special guest speaker who's going to be talking about a very hot topic in recent news time, if you will. So today we're going to learn more about Professor Avi Loeb from Harvard University about the fascinating hot issue of the mysterious interstellar comet 3I ATLAS and the growing interest in interstellar objects visiting our solar system. We're going to engage in an interactive Q&A at the end of it, and it's a great opportunity to discuss the implications of this comet for astronomy, astrophysics, aerospace industries, aeronautics, and astronautics. Before I turn it over to Dr. Loeb, I'm going to introduce him. So today we are honored and welcomed by Dr. Loeb, one of the world's most influential and forward-thinking voices in astrophysics. Dr. Loeb is the Frank Baird Jr. Professor of Science at Harvard University, a New York Times and international best-selling author, and a scholar whose work continues to shape our understanding of the universe. He earned his PhD in physics at just the age of 24 and went on to serve at the Institute for Advanced Study in Princeton before joining Harvard, where he became the longest-serving chair of the Department of Astronomy and the founding director of the Black Hole Initiative. Today, he leads both the Institute for Theory and Computation and the ambitious Galileo project. Professor Loeb has written 9 books, including Extraterrestrial and Interstellar, and has published more than 1,000 scientific papers, influencing fields from black holes and the first stars to search for extraterrestrial life. His impact has been widely recognized. He is an elected fellow of major scientific academies, former member of the White House PCAST, chair of the National Academy's Board of Physics and Astronomy, and past chair of the Breakthrough Starshot Initiative. Time magazine has named him among the 25 most influential people in space, and in 2024, Scholar GPS ranked him 3rd worldwide in research impact among astronomers. So with that, I am very excited to turn it over to Dr. Loeb.
Thank you so much for the introduction, Luis. It's a great pleasure to join you, and I'll be particularly interested in your questions. So you should regard my presentation as a prelude to the questions, and just to give you some background. So let me share my screen, just one second, and open up my slides. And I hope you can see everything. Okay, what you're seeing is just a month and a half ago, I was invited to a NASCAR car race in Bakersfield, California, not far from where you are. And it's because one of the racers decided to put my image along with 3IATLAS, this interstellar object that I'll discuss, on the hood of his car. And I told him that for me it's a great compliment, but not for 3IATLAS, because it's moving 600 times faster than any of the cars that will be participating in that race. So he taught me how to drive a race car and wanted me to join in Daytona very soon, but my wife objects to that. And then another gesture that I received a couple of weeks ago was from one of the most accomplished sculptors in the world. He donated, his name is Greg Wyatt from New York City, and he donated 2 bronze sculptures to my office, along with 51 watercolors that you can see in the background. These bronze sculptures are of Galileo Galilei, who discovered that we are not at the center of the universe. And the watercolors are of 51 scientists that had important insights. And this just illustrates that the scientific work that I'm pursuing is an inspiration to many, from car racers to artists. So that's, as far as I'm concerned, that's a great testimony to the fact that we should pursue the subject scientifically the way I'm trying to do. And this is a cover from a New York Times magazine issue that asked, why am I interested in looking for extraterrestrial civilizations or aliens? And the reason is quite simple. There are 100 billion stars in the Milky Way galaxy, like the sun, and most of them formed before the sun, because the sun formed in the last one third of cosmic history, just 4.6 billion years ago. Cosmic history is 13.8 billion years, exactly 3 times longer. So we are late to the party. And that's important to understand because, it takes less than 1 billion years for the Voyager spacecraft that we launched to cross the entire Milky Way galaxy. So they could have arrived to our doorstep even if they used technologies of the 1970s. Voyager will make it to the other side of the galaxy in less than 1 billion years. And most of the stars are several billion years older than the sun. So Enrico Fermi asked, "Where is everybody?" If I were next to him, I would say, "Enrico, that's a question that every lonely person asks. And what you tell a lonely person is that, you should not be so presumptuous. They would not come and join you for lunch. You should seek them." And he didn't build a telescope. Now, it's possible there is a lot of traffic already in the sky, but we just didn't look for it because the biggest rocket that we ever built is a Starship. And Starship is barely visible, even if you take it together with its fuel. If you take the entire Starship and put it at roughly a distance of the Earth-Sun separation, our best telescopes barely see it from the reflection of sunlight. So objects that are smaller than that, like most of the spacecraft that we launched, are not visible to our telescopes within the Earth-Sun separation. Now, people often say extraordinary claims require extraordinary evidence. First, I wanted to clarify it's not an extraordinary claim to say that something like us existed around another star, because we know that at least about 10% of all the stars have a planet the size of the Earth, roughly at the same separation. So the same physical conditions may exist in 10 billion stars within the Milky Way galaxy. And that's not a small number. So looking for something like us that existed before us is not speculative. It's completely a matter of common sense. Unfortunately, common sense is not common in academia. So this is an ordinary claim, and for that we just need ordinary evidence. And of course, if we don't seek the evidence, the way Enrico Fermi just asked the question without looking for the evidence, obviously we will not find it. Now, the mainstream of astronomy is focused on searching for microbes. They're obsessed with microbes. The highest recommendation in the astronomy and astrophysics decadal survey was to invest more than $10 billion in the next 2 decades to search for microbes. Now, you might say, okay, well, there are many houses on our cosmic street, and we have plenty of microbes in our house, the Earth. So most likely there are plenty of microbes out there. That's fine, but to find them from a distance is very challenging. That's why it costs more than $10 billion. And even then, if we detect oxygen, methane, water, molecules in those atmospheres, these molecules can be produced by geological processes. It's not clear that we will have a definitive proof that they exist, even the microbes. But my point is, if there is a resident, an intelligent civilization out there, then they may show up at our front door. They may throw a tennis ball that we'll find in our backyard, or they may have some construction project that we can see at a distance. So it may be much easier to find one resident in our neighborhood than billions of microbes. Who cares? Like, they are difficult to find. And it makes much more sense to hedge our bets and put billions of dollars towards both tasks, because the chances are not known of finding one or the other. We should hedge our bets. Again, that is not the situation right now. The situation is that the astronomy community recommends investing more than $10 billion in the search for microbes and $0 in the search for technological signatures. Zero versus 10 billion. That's not reasonable. Now, the US government, the intelligence agencies, they report about objects they cannot identify in the sky. That's a serious matter because basically they're saying we are not doing our job. And the defense budget for 2026 is $1 trillion. The US defense budget is $1 trillion. We are putting $1 trillion to the defense, to the Pentagon, and they are not doing their job. That's a serious matter. There are objects they cannot identify. They admit that. So there are two possibilities. Either, someone else needs to do the work for them. For example, scientists looking at these objects in the sky, trying to figure them out. And obviously, they would keep it under wraps. They will not, they will classify all these objects that they cannot identify. Why? Because they don't want to be scrutinized. Because if they were to show the evidence to the public, it would demonstrate that they're not doing their job. So they classify it. Nobody can look at it. Great. Now nobody can criticize them for not doing their job. Now, the second possibility is that these objects are not made by adversarial nations. So it's not a matter of national security. And in that case, it's the most important discovery that humanity ever made. But in both cases, someone should look into it because they admit that they're not doing their job. And so I decided to lead the Galileo project, and we build observatories. Right now, we have 3 observatories that we already constructed, collecting data on millions of objects every year and analyzing them with machine learning software, just to figure out if all the objects in our sky are within the flight characteristics of human-made technologies. So we have a set of infrared cameras monitoring the entire sky, a set of visible light cameras, a radio sensor, and an audio sensor. And we analyze the data with machine learning software, looking for outliers. The most recent observatory was put on top of the Sphere in Las Vegas. The owner of the Sphere, which is an entertainment center that cost $2.3 billion, he came to my home and asked me to build a Galileo observatory on top of the Sphere. And that was a year ago, and this summer we did it. So if you ever fly above the Sphere, you could see it as a pimple on top of this 130-meter structure. And this is us going this summer to put it there. You can see it behind me. And on the left, you can see a video that shows how challenging was the construction of this on top of the Sphere. We had to make sure that we don't bump our head against all these metal pipes out there. Yeah. And this is how it looks from the top of the Sphere. And you can see this is the set of infrared cameras that we put together, looking at the sky at all times. And in the background, you can see Vegas. The one thing is clear that anything that we find in this data, everything that happens above Las Vegas will not stay in Las Vegas. So we will violate this rule that everything that happens in Las Vegas stays in Vegas. And there are 2 other observatories, one in Massachusetts and another one in Pennsylvania, that are operating and collecting data. But what I'll mention mostly is the new frontier in astronomy, which is interstellar objects. These are objects coming from outside the solar system. And we know that because they're moving too fast to be bound by gravity to the sun. So we measure their speed, and we know that they're above the escape speed from the solar system. And the first one was actually discovered by my student and myself. It's a meteor, half a meter in size object that collided with Earth in 2014 and was recorded by US government satellites. And then there was, in 2017, an object discovered by a survey telescope in Hawaii, given the name Oumuamua, which means a scout in the Hawaiian language. And then 2 years later, there was a comet that looked just like the ones we have in the solar system, called Borisov. And then this year, on July 1st, there was a comet, an object discovered by the ATLAS telescope in Chile. And this one actually captured the public's imagination and curiosity because it had a number of anomalies that I pointed out. One of them that you can see at the bottom of this slide, you can see the arrival of 3IATLAS into the solar system. It was within 5 degrees of the plane of the planets around the sun. And the chance of that happening at random, such an alignment, is 1 in 500. So this is the third object, and yet, we should have seen hundreds of them before we see one that is so well aligned. And the question arises whether the trajectory was designed by some intelligence, and that's why it arrives in the plane of the planets. There is no natural reason for that. Most of the objects, the other ones in particular, came at a large angle. And then you can see on the top right an image from the Hubble Space Telescope, which shows a glow, a halo of a glow around the object that is extended in the direction of the sun. Very different from the comets that we are familiar with that have a tail. This is an anti-tail. And this was observed first on July 21st, as the object was about 3 times the Earth-Sun separation from Earth, so it was approaching the sun. But actually, 2 days ago, a new image from the Hubble Space Telescope was taken after the object passed closest to the sun on October 29th. So now it's heading away from the sun. And guess what? This anti-tail is still an anti-tail. In other words, it's the reverse direction relative to the motion of the object. So previously, the object was moving towards the sun, and this anti-tail was pointing towards the sun, in difference from cometary tails that usually point away from the sun because the gas and dust are being pushed by solar radiation pressure and the solar wind. So it was an anti-tail that we don't see. It's not normal for comets in the solar system. And then once it passed the sun, the anti-tail continued to be pointed towards the sun. So in other words, now it's opposite to the direction of motion because it's moving away from the sun and the anti-tail goes towards the sun again. So the latest image from the Hubble Space Telescope is similar to the one you see here, except the direction of the elongation is now reversed relative to the direction of motion. And I should say the Webb telescope found mostly nickel with very little iron around it. That's quite uncommon. We've never seen it in a natural object. Usually nickel and iron come together, except in industrially produced nickel alloys. So the authors of the papers that reported about nickel with little iron said, oh, maybe the same process that we have in our industry is operated in nature, the carbonyl pathway. We've never seen it before. Is it a technological signature? We don't know. And after it passed closest to the sun, we detected jets coming from it. Amateur astronomers actually provided us with a lot of information. I call it science of the people. It's not the way I define science is that the foundation of science is the humility to learn. It's not the arrogance of expertise. So NASA had a press conference a week ago, and they showed the arrogance of expertise. The experts are telling us what it is. Whereas, it's really the third object. You can't have experts on interstellar objects because we only saw 3 of them. And therefore, we should have the humility to learn because we are still in the learning process. And so these amateur astronomers obtained beautiful images, much more informative than the NASA images. And they did it with telescopes that cost only a few $1,000s compared to the NASA instruments that cost $1 billion. It's the humility to learn. The NASA image is shown here at the best NASA image was shown at the press conference. It's at the lower left here, taken by the high-rise camera on board the Mars Reconnaissance Orbiter when the 3IATLAS came closest to Mars on October 2nd at a distance of 30 million kilometers. But it's very fuzzy. This image is not great because the camera was jittering. Look at the images. The other images were taken by amateurs over the past few weeks. And in particular, the one at the bottom, middle bottom, shows multiple jets coming from 3IATLAS. And I would very much like to know whether the jets are produced by pockets of ice that are illuminated by sunlight and get sublimated, a natural process, or they are thrusters on a spacecraft. And it's easy to tell the difference if you measure the velocity of the gas in these jets, because the sublimation of ice under sunlight only results in thermal speeds of order 400 meters per second, less than a kilometers per second, whereas rockets result in a few kilometers per second exhaust speed. And ion thrusters result in tens of kilometers per second. So it's easy to tell the difference between technology and natural processes if we could only measure the speed of these jets. And they extend to about 1 million kilometers, these jets. So there are lots of unusual properties, anomalies of 3IATLAS. And one of them is that it will arrive on March 16th, 2026, closest to Jupiter, and it will be exactly at a distance of 53.5 million kilometers, which happens to be the distance that Jupiter's gravity dominates over the sun's gravity. That's called the Hill radius. And why would it come to that distance exactly to within 4 significant digits? We don't know, but that's the case. And part of it was a result of non-gravitational acceleration that affected its motion when it came closest to the sun. So with this course correction, it's arriving spot on the Hill radius of Jupiter. Chance for that at random is 1 in 26,000. There are other anomalies in addition to the ones I already mentioned, but I will not get into them. I defined back in July a classification scale that is called the Loeb scale, where 0 means that an interstellar object is natural and 10 means that it's a potential threat from alien technology to Earth. And the question is, after we get all the data, where will we put it on this scale? That was never discussed in detail anywhere because we only have planetary defense against rocks. We know the dinosaurs were killed 66 million years ago by a giant rock, but rocks are easy to forecast, their trajectory and so forth. If there is an alien technology, it might maneuver, it might have an intent, and it might include technologies that are superior to ours. It's a very different risk. And that's why I'm saying it could be a black swan event where the astronomers say, oh, at the 98% confidence, we are sure it's a comet. But the 2% likelihood that it's not a comet should be taken seriously because the implications for humanity would be huge. These are called black swan events in the context of intelligence. You can't ignore them. In fact, our intelligence agencies put most of their funding towards events that never materialize. Why? Because we can't afford the risk. If we take that risk, we will have another September 11th event. Israel will have another October 7th event. These are events that the intelligence agencies assigned a very small probability to, and therefore ignored them, and then they materialized, and they caused a lot of damage, a lot of deaths, and that we cannot afford. So a black swan event is taken seriously since then. And what scientists do not understand is that in the context of a visitor to our backyard, we should take seriously even a low probability event because the implications to society are great. This is not true for the explosion of a star at the edge of the universe. Who cares? It will not affect our life. But if there is something passing by and there is a 1% chance that it has technological anomalies, it must be taken seriously. It cannot be ridiculed. And after communicating with various Congress people, I mean, Congresswoman Anna Paulina Luna sent letters to NASA encouraging them, after I spoke with her, to take as much data as possible. And unfortunately, during the government shutdown, there wasn't much coming from NASA, and they didn't really take that advice to heart because they had a press conference just last week, and they basically said that there is not much. I mean, this is just a comet, and it just came from another environment, and we should all feel relaxed about it. But if we ever find the clear technological signature, the question is what to do the next day. And I encourage the United Nations to think about it, to build a committee or an organization that will take care of that. And so far, not much response. But the time it happens, obviously after that, everything will change. The first interstellar object that was discovered by telescopes was Oumuamua, and that one has different anomalies. It was most likely flat, based on the fact that the light, the sunlight reflected from it changed by a factor of 10, the amount of sunlight, as the object was rotating every 8 hours. And the object also showed a push away from the sun without any evidence for carbon-based molecules, either gas or dust around it. So it was not a comet. It didn't show the features of a comet. The experts are arguing it's a dark comet where you can't see the tail. And I feel like the kid in Hans Christian Andersen's tale saying the emperor has no claws. I don't see them. This comet has no tail. The experts say, well, it's a dark comet, which is basically an oxymoron because they're saying that it showed the behavior of a comet, except it didn't show the features of a comet. So it's a dark comet, but anything like a spacecraft could be a dark comet. And I argue that perhaps the push is coming from sunlight. And in fact, 3 years later, in 2020, there was an object that was discovered that was pushed by reflecting sunlight. And it was realized after the spectrum of this object was taken that it's actually made of stainless steel. And it's a rocket booster that was launched by NASA in 1966. I should also mention that on January 2nd this year, the Minor Planet Center, full of experts on comets, cataloged a new asteroid. And then a day later, they realized, oh, wait a minute, this near-Earth asteroid actually follows the path of the Tesla Roadster car that was launched by SpaceX in 2018. So it's not a rock, it's a car. And they took it out of the catalog. The only reason they knew it's a car is because they knew that SpaceX launched it. But if there was a more accomplished space entrepreneur since the Big Bang than Elon Musk over the past 13.8 billion years, and there would have been a car entering the solar system from outside, we would not know about the launch trajectory, and the Minor Planet Center would announce it as a rock of a type that we've never seen before. And when people say, that Oumuamua was a dark comet, it's just like experts that are specialized in studying zebras will go to the zoo and see an elephant. They would argue the elephant is a zebra without stripes because that's what they're trained on. All I'm saying is they behave just like AI systems that are trained on a data set that is limited. And I'm saying, in addition to rocks, you should expand your training data set to include also technological objects, because we know that we launch technological objects to space. So there must be some there. And therefore, you can't just assume that everything is rocks. And the next Copernican revolution would be that, we are not alone. And This is a real image of the Tesla Roadster car that had a camera attached to it, and you can see the Earth in the background. And this is the object that the Minor Planet Center cataloged as a rock until they realized that it follows the path of the Tesla Roadster car. So it is a rock, it's red, and but it's a rock of a type that they've never seen before. And by the way, if a cave dweller were to find a cell phone, the cave dweller would say it's a rock, the cell phone is a rock of a type that I've never seen before. And I already mentioned that the Voyager spacecraft will be on the opposite side of the Milky Way disk in 1 billion years. So I led an expedition a couple of years ago to search for the materials from the first interstellar meteor. It exploded in the Pacific Ocean, and we went there after the US Space Command confirmed the assertion that this meteor was interstellar based on its measured speed. And I led a team, you can see it on the deck of a ship that was called the Silver Star, and there was a Netflix documentary filming crew that came with us, and the Netflix documentary will come out next year. We used the sled that was covered with magnets, and we placed it on the ocean floor to collect magnetic particles left over from the explosion of this meteor. And we put all the materials that were collected by the magnets in the suitcase, the black suitcase on the right side, and I brought it to the laboratory of my colleague Stein Jacobson at Harvard University. And we analyzed the materials. We found about 850 spherules. These are molten droplets that you can see here. One of them, we extracted them with tweezers and studied their composition. And we found that about 10% of them have an unusual composition, chemical composition, that was never reported in the scientific literature and is not familiar from any material in the solar system. What you're looking at here is the abundance of elements on the vertical axis relative to the solar system composition. And on the horizontal axis are various elements organized by their volatility. So elements on the right-hand side are very volatile. They can be lost easily in an explosion, in a fireball of a meteor. And indeed, we are missing them in those spherules, in those molten droplets. And some elements that are not so volatile are found with an abundance up to 1,000 times the solar system materials. These are elements like beryllium, lanthanum, uranium. And so we could find only these tiny droplets, but we hope to have another expedition. We are waiting for a funder for that so that we can find bigger pieces of that meteor and infer the nature of the original object. We have a ship and we have a robot that we hope to put on the ocean floor, but we're still in need of funding to do that. And as of June 2025, there is a new observatory that was funded by the Department of Energy and the National Science Foundation in Chile. It's called the Rubin Observatory, and it's the best that was ever constructed to survey the sky. It will survey the southern sky every 4 days, and will use a camera that has 3.2 gigapixels. About 1,000 times more pixels than your cell phone camera. And the calculations show that it's expected to discover new interstellar objects every few months. So we are entering a new era now that we can actually see objects in the sky and can address Enrico Fermi's question quantitatively whether we are being visited by any technological objects. And I expect the coming years to be very exciting. Thank you, and I'll be happy to answer any questions you have.
Okay. Wow. Thank you, Dr. Loeb. That's great. Thank you all. So now is the time for our Q&A. Please, if you have a question, you can either put it in the Q&A chat. I can read it for everyone online and in the room, or you're welcome to raise your hand, come off mute, and ask your question. And obviously, for anyone in the room, please ask questions as well whenever you're. Okay, so I see someone has their hand raised. Itamar, we'll start off with you.
We can't see you, Itamar.
They were given the mic, so they cannot show their camera, but they can speak up.
Right.
I think
If
it's ready.
maybe yeah, maybe we can get started with the question that's in the chat right now from Zohar. So thank you for this talk, Professor Loeb. Would the search for microbes, and this was a question dropped at the beginning, towards the beginning of your presentation. Would the search for microbes allow investigators to also search for an industrial signature in the same spectra analysis?
Yeah, that was the suggestion that I made back in 2015. I wrote the first scientific paper suggesting that we can also search for industrial pollution in the atmospheres of exoplanets using the same instruments, the same spectrographs that are looking for oxygen or methane. And, when people motivate the search for biosignatures of microbes, they don't often mention that. And it's just a state of mind. They don't want to take any risks. And I find that's very strange because we show that the industrial pollution at a level that is 100 times bigger than what we did so far could be detected. And you might wonder, why would industrial pollution at a much higher level happen? Well, for example, if you wanted to have global warming for a good reason, because the planet is too far from the star, so that usually it's frozen, and if you want to keep it warm, you will put a blanket of pollutants. So that is, even if those that are environmentally friendly don't want to think about aliens being environmentally unfriendly, you might consider the fact that a frozen planet will become a good background for life if they were to put a blanket around it and warm it up.
Great. Okay. Looking at the chat here again, a question from William. Our extrasolar system objects like Pioneer have intended technology for communication. Do you suppose another civilization would take the same approach?
No, you have to understand that everything that we launched was to a relatively nearby target within the solar system. But once you exit a planetary system like the solar system, the light crossing time from the edge of the solar system, which is halfway to the nearest star, this is called the Oort cloud, the outskirts of the solar system, the light travel time is 2 days. Okay, so it takes 2 days for light to travel from the edge of the solar system to us.
Mm-hmm.
Now imagine going to another star. That could take on the other side of the Milky Way galaxy, it could take several thousand years for the light to go one way. So that means the spacecraft, if it needs to make a decision of what to do, or if it wants to send a report, the report will arrive thousands of years after it's sent, and by then it will be completely irrelevant. So when anyone sends a spacecraft to an interstellar journey, one needs to equip that spacecraft with a brain of its own. It needs to have artificial intelligence. We haven't yet launched a system with AI to space.
Okay.
We didn't do that, but it will be necessary, required to include AI in an interstellar system because it has to decide by itself. It cannot wait for guidance from the Jet Propulsion Lab in Pasadena, the way that currently all the rovers that we send to Mars, they are just they have a parachute parenting from JPL. The helicopter parenting, sorry.
Yeah.
And in fact, there is a helicopter on Mars that is being that was parented by JPL engineers. And that is not a viable scenario for going to distant locations outside the solar system. You have to allow the system, the probe to be autonomous. And it's sort of like thinking about your kids. Once they leave your home, they can send you a postcard or give you a call every now and then, but they don't depend on your decisions. And that's the way we should regard interstellar travel. And it's definitely the case with things that arrive to our backyard, that they should be independent if they're functional.
Okay. Yeah. Good. Okay, Dr. Loeb, the questions are coming in now. So switching over to the Q&A, question from Aaron Rodriguez. So you have said that on December 19th, the interstellar object 3I ATLAS will approach Earth, and we will have the opportunity to learn more about its nature. What telescopes will be used?
Yeah, so there are 227 telescopes that looked at it when it was approaching the sun. I'm very much hopeful that all of them and more will be looking at it when it comes closest to Earth, now that it passed perihelion. And there is the International Astronomical Warning Network that announced a campaign where they coordinate observations in the coming 2 months to get as much data as possible about 3I ATLAS. In addition to that, I expect data from the Webb telescope, and already there was a data from the Hubble telescope released 2 days ago. And in addition, there are some spacecraft in the solar system. Actually, just last week, the JUICE mission of the European Space Agency took data of 3I ATLAS, and ESA released an image from the navigation camera that is not a great image, but at least indicates that 3I ATLAS was observed by JUICE. And the data from JUICE will arrive. This is a Jupiter mission. The data will arrive in February 2026, because right now the communication setup is being used to protect the spacecraft from sunlight. It's a shield until February, where it will be used for transmission. So the amazing thing is that despite the fact that JUICE came relatively close to 3I ATLAS within 50 million kilometers, 3I ATLAS will get closest to Jupiter on March 16th, 2026. And JUICE, which is heading to Jupiter, will get there only in July 2031. So just think about it. Two objects aiming to get to Mars. One will get there just in 3 months or 3.5 months. And the second, the human-made object, will get there only in 2031, in more than in 5.5 years or so.
Yeah.
And of course, the reason is the speed of these objects.
Right. Okay. Thank you. Question from Lahari Ganti. Thank you for presenting. It was very interesting. At the moment, where would you place 3I ATLAS on the Dr. Loeb risk scale?
Yes. So back in July and August, I ranked it 4. And that was with very limited data. And I have a lot of fans. I have, I think by now, 115,000 people who read every essay I put on medium.com once a day or two. And about 5 million people a month that read my essays. It's getting larger and larger. So, every month I have 5 million readers, and they keep asking me, what is my rank? What is my ranking? And by the way, this popularity that I'm getting has resulted over the past 2 weeks. There was a creator using AI to produce fake videos with fake content of me speaking. And they created a YouTube channel where they display these videos. As soon as they were put there, these videos that are AI created, by now, within 2 weeks, they got 1 million views. And moreover, there was a reporter from a news outlet that used one of these fake videos when discussing my research. Now, I was very upset about this because I don't approve the content of these videos.
Yeah.
And So I filed reports to YouTube, and they did not respond. I mean, it took them a while. And then I put it as an addendum to my essay yesterday. And within a day, that channel disappeared. Now, I thought, great. Somehow the message got to these people because I said that they are legally liable to defamation, to, they're impersonating me without my consent. These are legal violations of the rules of YouTube. And uh, then someone sent me an email with a new link for a channel on YouTube. So what they did is transfer it to another link. And I reported about that as well to YouTube. Let's hope they will get rid of it. But it's really an issue for the future that, a scientist like myself, for us, it's really important to attend to facts that describe the physical reality. And when AI content includes counterfactual information, misinformation, it's really troubling. That's the biggest enemy of science. And the question is, how can the public tell the difference between fake content produced by AI and real content? Right now, maybe you can tell that the AI video is not real. And some of my fans did that because the clock behind me was not ticking, was not moving in the fake video. But in the future, the AI will get more sophisticated, and I think it's a real danger. And my advice to young people is to look always at primary sources, try to figure out if something is fake or real. Because this problem with AI will get worse and worse over time. But at any event, yeah, I hope in the first part of my reply, I answered the question.
Yeah. And yeah, I hear you on the AI thing, but good to know the context of the popularity there. So moving on, a question from Jeff Overbeek. What are your thoughts about whether other civilization visitors are peaceful?
Yeah, so when you go on a blind date, and I don't know if you did go on a blind date when you were young. I met my wife on a blind date. Obviously, you are always hopeful that the dating partner will be friendly, but it's often a matter of luck because every now and then you might have a dating partner that is a serial killer. So, what do you do? How do you figure it out?
Yeah,
Well,
yeah.
my answer is, my answer is don't speak. Observe the other side. That's my advice to young people that go on blind date, or maybe not just young, in general. If you go on a blind date, listen to the other side, observe it before having an opinion.
Yeah, good one. Okay, so I know Itamar raised his hand earlier, but now he has a question in the chat. So, how sure can we be that signatures of extremely advanced technology or biosignatures of very different biology to our own can be seen and recognized?
Well, that's a great question because that's my point about those biosignatures that are molecular, specific molecules in the atmospheres. You have to demonstrate that these molecules, even if you detect them, which is extremely challenging, by the way, finding oxygen and so forth. But even if you find those molecules with the next generation telescope that will cost more than $10 billion, then the question arises as to whether these molecules were produced by some natural geological process. And, it will not be easy to prove beyond any reasonable doubt that that's the case. But this is what the mainstream of the astronomy and astrophysics community recommends doing for the next 2 decades at a cost of more than $10 billion. And in the same decadal report, there was no funding allocated to the search for technological signatures. That's what I'm arguing about, that we should hedge our bets because it doesn't make sense to go in this direction that is so difficult. Of course, microbes might be more abundant, but finding conclusive evidence for them is extremely difficult, and it might not be conclusive. But if you find technological signature, it might be obvious. If we don't invest billions of dollars in that direction, we might not find anything, and we will maintain our ignorance. I'm saying it's just a matter of common sense to invest in both directions. And moreover, if you ask the public, and I did ask the public, there was recently a poll that we conducted in a survey. The public is far more interested in the question of whether there is an intelligence out there than in the question of whether there are microbes out there. And the public funds science, through taxes. So the fact that the scientific community says, give us your taxpayers' money, give us $10 billion, and we know what to do. We don't want to do what you want us to do. We know what to do with it. We want to look for microbes, period. That's not a nice gesture towards the public. And that's why the public thinks that science is work of the elite.
Mm. Yeah, I think that's good point. Sensible. So I want to be respectful of the people in the room. If anyone in the room has a question, please go ahead and ask before. If not, we'll jump over to Mark's because he's got his hand raised.
Yeah, will his slides be available either for download or on the web?
I can send it to one of you, and then you can share it on some drive if you want. But
yeah,
don't share it publicly. Just share it to the group. Yeah. And
Okay.
also, you could look at the video again. I guess it's recorded, right?
that is correct.
Yeah.
It is recorded. Okay.
Okay. You can send it. You said you can send the slides.
Yeah, someone should send me an email and I'll share it.
Okay. Do you have your email in the?
Well, Louis
Yeah.
can.
Yes. We'll coordinate that. Again, like Dr. Loeb mentioned, this is being recorded, so we will follow up with you on that. Okay. Mark, please go ahead.
Sure. I put this in a chat earlier, but because this body seems to be close to the ecliptic plane, and I think you said that it had about a 1 in 500 chance randomly from coming from that direction. It seems to me, at least, that that it might have been an object from the Oort cloud that was accelerated by a distant heavy planet, unknown planet. Okay. Planet X of some sort.
Well, the planets do not extend into the Oort cloud. The Oort cloud is outside of where the planets are.
Well, I don't know how heavy bodies would be.
Okay, there is another issue that this object was moving at 60 kilometers per second relative to the sun when it entered the solar system. There is no planet moving at this
that would
speed.
give it that acceleration. Okay.
Not acceleration, I'm talking about the speed.
Yeah, it's escape.
Even if it was a rocket moving, you need the rocket to be moving at 60 kilometers per second. There is nothing moving at that speed.
Right, and it's escape velocity plus its excess velocity.
It's on top of the escape.
Correct.
This is outside the solar system. It was moving at 60.
Okay, you got me. Me.
And another thing to point out is that the plane of the Milky Way galaxy is misaligned with the ecliptic plane by 60 degrees. So someone tried to suggest, maybe all the objects are coming from the Milky Way disk, but it's 60 degrees away from where the ecliptic is.
Okay. Ian, I see you've got your hand raised, and your question was next in the list, so go ahead.
Oh, okay. Can you hear me?
Yes.
Yes. Sorry. Yeah. Well, I'm sure you've seen or aware of this from reading papers and so forth. Some stars have been analyzed by astronomers with the peculiar IR signatures, and there have been some hypothesis or speculation, if you will, whether these could be Dyson spheres or rings. And is that the possible indication of a Kardashev type 2 civilization?
No, at the moment, we think that the infrared signatures are most likely debris disks. So when you make a planetary system, first you make the stars, and then the stars is being fed through a disk of gas, and then there is some debris left over from the formation of the star, and we see those debris disks. They are full of rocks, and they have dust in them, and we can see emission in the infrared. So there is a surplus of infrared emission from these disks that is associated with the dust in them. So that's not surprising, actually, for us to find infrared emission around young stars. So far, there is no case that is clearly abnormal in terms of it being evidence for a Dyson sphere. A Dyson sphere is, by the way, is a major engineering project to build some structure around the star in order to capture most of its light. And it cannot be a solid structure because it will break apart because the tension would be so great. And the other thing to keep in mind is that any such structure would only be for a limited time because the star evolves and becomes brighter towards the end of its life, and it will basically break the Dyson sphere apart. And I suggested that if, like for Oumuamua, was indeed a thin layer, a thin membrane, it could have been part of a Dyson sphere that was broken apart. It could be just a piece of a Dyson sphere that is floating. So when you break apart a Dyson sphere, you'll end up with pieces flying through interstellar space, and they will likely be thin because they need to hover and just maintain some shape around the star, and the best way to do that is with light sails, and that was suggested by Robert Forward as a concept for a Dyson sphere. So once the star gets brighter, it will push them out and break apart that configuration, and then you will end up with objects like Oumuamua that can be easily pushed around by sunlight.
Yeah. Okay. Thank you.
Okay. Question from Stuart here.
Okay.
Where-
We have a few more minutes because I need to go in 5 minutes or so.
Okay, yeah. Sounds good, Dr. Loeb. Want to be respectful of your time. Where did 3IATLAS come from? Do we know if it intercepted any other stars?
Well, so our Oort cloud, that represents the outskirts of the solar system, extends halfway to the nearest star. So that means if the nearest star system is Alpha Centauri, and that means if it has an Oort cloud around it, the Oort cloud of all the stars are touching each other. They're just like densely packed billiard balls. So if you move in any direction, it doesn't matter which direction, you will pass through many Oort clouds of many stars, a lot of them. And we would never know where an interstellar object came from, irrespective, if it's natural, for example. And unless we know, of course, the duration of the journey. If you know the duration of the journey, you can tell from where the object came, but we don't have a clue about the duration of the journey. There is no clock on this object, at least one that we can see, that would tell us how long it was traveling.
Mm-hmm. Okay. Okay. Well, let's see. Last question here. So, Volca, they say, hello, I'm 11 years old. How long did the installation of the Galileo project, the one on top of the sphere, take?
That was a matter of a few weeks, but we built the instruments for a few months before that. We just had to put it up there. So just putting it up there was a few days at a time. We put first the infrared instruments, and then in another week, we put the visible light instruments. But it's just a matter of a few days. In fact, we could have done it in one night if everything was smooth, but we had to do some fixing. And the first installation was actually overnight. We started at 4 a.m. in the morning and finished by around noon because it was getting very hot during the summer. Anyway, since you are 11 years old, I would highly encourage you to keep your childhood curiosity and become a scientist or an engineer in the future, because the young generation of today my hope is that it will solve all the puzzles that my generation failed to solve.
Wow. Well, thank you, Dr. Loeb. And on that note, I want to thank you for taking the time today to speak to us. It was a very, very interesting topic. Thank you for all that you're doing and all that you're working on, and the outreach that you're doing. We're very happy, and if you're up for it, we would like to stay in contact and maybe invite you for another one of these discussions in the future.
Thank you so much. I would love to do that. And feel free to post the video wherever you want. It should be fine with me.
Fantastic. Also, I want to give a quick shout out to Ken in the room there. Ken, please raise your hand. Yeah, that's Ken. He was responsible for setting this all up. Thank you so much, Ken. I appreciate you and your hard work. Thank you to everyone for attending. Again, we're the AIAA section. If you found value in this, please become a member. We're always looking to grow our aerospace and aeronautical community here. Again, thank you, Dr. Loeb.
Thanks for
Now,
having me.
Are you going to send us an email? You said you're going to set up.
Yeah.
Yes, we will follow up with you. Just send an email out to the email in our newsletter, or reach out to Ken or myself. I'll drop my email
Well,
off.
I don't have any of that contact information.
Okay, I will put my email in the chat, and
Okay.
you can pick it up there.
Okay.
Thank you.
Thank you. Thank you.
Ken, you have